Okay, now next topic is potential energy of a dipole in uniform electric field. So, when a dipole is kept in an electric field, it acquires some potential energy. So, how? Say, therefore, how to define potential energy of a dipole? Okay, it is the energy possessed by the dipole by virtue of its position in the electric field. Okay, so the potential energy of a dipole is the energy possessed by the dipole by virtue of its position in the electric field. Right, now we are going to derive the expression for it. Now, say consider, say for example, suppose a dipole of moment, dipole moment, electric dipole moment is P, okay, and it is kept at an angle of theta with the direction of uniform electric field. Therefore, the angle between E and P is theta. Okay, uniform electric field is E. So, a dipole of dipole moment P is kept in an electric field, okay, at an angle that is theta. Okay, therefore, definitely it will experience a torque. Therefore, torque on the dipole, okay, that is given by what is a tau, that is equal to, okay, P sine theta. This is the torque, right? And what is the function of the torque? Torque tends to, for example, this is the electric field already. You have seen, see, this is the electric field, uniform electric field. And now, this is the dipole. This is the dipole. This is minus Q and this is plus Q. Therefore, what will be the direction of the torque? Torque will tend to, it will be anti-clockwise, it will tend to align the dipole in the direction of the electric field, correct? Therefore, this will turn like this will turn like this, right? Therefore, this, but now what I want, so what is the angle between them? Initially, the angle is, what is that? It is kept at an angle of theta, right? And P will be, what is the direction of P? P will be in this direction. Okay, therefore the angle between P and E is theta. Therefore, definitely torque, it experiences a torque that is equal to P sine theta, which will align the dipole, try to align the it tends to align the dipole in the direction of the electric field, right? But now what I want is, I want to move the dipole through, now it is at an angle theta, right? Okay, now I want to rotate the dipole in this angle, opposite. I want to rotate the dipole, okay, in this direction, okay. Therefore, through an angle that is equal to d theta. Through an angle d theta, okay. Therefore, against the torque. Why? Torque will be acting in the anti-clockwise direction, but I want to move the dipole through an angle d theta against the torque. Therefore, what I think, this is very simple. Some work has to be done against the torque. Therefore, what is now we are going to see? What is a small, okay, amount of work done, okay, in, for what? In rotating, okay, the dipole, in rotating the dipole through a small angle. What angle? D theta. Small angle d theta against what? Against the torque. Because torque will move in anti-clockwise direction. I want to move in the clockwise direction through an angle d theta. Therefore, that small amount of work done is dW. Okay, what is dW? What done? So, if it is linear motion, work done will be, what is work done is equal to F into S. But in the rotational motion, F, that is equal to tau into theta. Correct? Therefore, here dW means it will be tau into d theta. Okay. Therefore, that is dW. What is tau? P sine theta d theta. This is the very small amount of work done that has to be done in order to rotate the dipole through an angle d theta against the torque, right? Okay, but now I want to move the dipole, okay, from an orientation theta 1 to theta 2. Theta 1 to theta 2. For that, how much amount of work has to be done? That we are going to see. Therefore, work done, okay, in rotating the dipole from, okay, angle theta 1 to theta 2. That is nothing but W. W is nothing but integral of dW. That is the integral of theta 1, theta 2, P E sine theta d theta. Okay, and what is integral of sine theta? That is equal to P E sine theta d theta, theta 1 to theta 2. Right, that is W. Clear? Therefore, what is W? Therefore, what is W? W, that is equal to P. Integral of sine theta is minus cos theta now. Cos theta, and angle is theta 1 to theta 2. Therefore, that is nothing but minus P. Minus sign you take outside. Therefore, you will be getting cos theta 2 minus cos theta 1. Correct? Upper limit minus lower limit. Okay, and this work done, yes, stored in the dipole as what? As potential energy. Are you following? This work done is stored in the dipole as potential energy. Therefore, potential energy of the dipole, U, that is equal to minus P cos theta 2 minus cos theta 1. Okay, so this is the expression for the potential energy of a dipole. Are you following? Right. Now, special cases. Number 1. Okay. See, when the dipole is initially aligned in the direction of the electric field. Okay, in the direction of the electric field. Therefore, initially, what is theta 1? Initial angle is theta 1 na? Theta 1, it is 0. It is because it is aligned in the direction of the electric field. Right. Now, and I want to rotate it through an angle theta. Initially, it is aligned in the direction of the electric field. From there, I want to rotate it through an angle theta. Therefore, what is the theta 2? That is equal to theta, right? So, therefore, what is the work done? Therefore, what is the work done? Work done, that is nothing but the potential energy. That is equal to, substitute, minus P cos theta 2. What is cos theta 2? Theta 2 is theta na? Minus cos theta 1, cos 0. Cos 0 is 1. Are you following? So, this is the potential energy, work done, or potential energy when initially at what is that? E and P are aligned in the same direction. Theta 1 is equal to 0. From there, I want to move it to an angle theta. Therefore, this is the case, right? Number 2. See, initially, okay, the dipole is aligned at an angle of 90 degrees with the electric field. Okay, it is what is theta? Theta is the angle between dipole moment and the electric field. Therefore, dipole is aligned at an angle of 90 degree with the electric field. And from that, I want to turn it through an angle theta. Okay, therefore, what is the work done and what is the potential energy? This potential energy is nothing but electric potential energy. Okay, right. Therefore, that is nothing but, what is that? Minus P P. Okay, and cos theta 2 is theta minus cos 90 now. Therefore, that is nothing but minus P cos theta. Fine. Minus P cos theta. Therefore, you can even say that as U. That is potential energy, that is nothing but minus P dot E. Minus P dot E. Are you following? So, therefore, when it is initially at an angle theta, but after that you want to move it through an angle, initially at an angle 90, after that you want to move it through and rotate to an angle, what is the theta? Therefore, this will be the potential energy of the dipole. Okay, and you know that potential energy, what is the unit for potential energy is nothing but joule. It is energy, therefore it has to be a scalar quantity. Hope you are following that. Okay.